Howdy! In this mini lecture, we will explore advanced techniques for extracting fossil fuels and their environmental impact. Additionally, we will also discuss technologies used to minimize the environmental impact of harvesting and/or using fossil fuels. The student learning objectives of this mini lecture are: describe advanced techniques used to extract harder to reach fossil fuels, outline the environmental impact of classic and advanced methods for extracting fossil fuels, describe features of clean coal technology, and describe how directional drilling is used to minimize the impact of fossil fuel extraction. While fossil fuels make travel easier, increase our lifespans by providing products that promote or protect health, such as surgical, tubing, and pharmaceuticals, and increase our material standard of living, they have drastic negative effects on our health and the environment. Also, we discussed in part 1 video of fossil fuels, we have already extracted the easy-to-reach reserves of fossil fuels, so efforts are being made to develop technologies to extract harder-to-reach reserves or resources. We will consider both of these issues as well as strategies for conserving and enhancing energy efficiency in this video. Because the easily extracted fossil fuels have already been harvested, we now must rely on a number of new approaches to extract more fossil fuels. These methods include secondary extraction from existing wells, hydraulic fracturing for oil and shale gas, offshore drilling in increasingly deep waters, moving into ice-free waters of the Arctic, and exploiting unconventional fossil fuel sources. These efforts will reduce the EROI of fuels because we are having to invest more time, money, energy, and resources into extracting the fossil fuels that remain in the ground. We can expect as we pursue these options, the cost of fossil fuels will increase and pollution and climate change will intensify. For example, the oil sands in Canada and Venezuela are already increasing available oil, and known deposits of oil shale may contain more oil than all conventional crude oil in the world. These oil sands and the oil shale that is found under federal land in Wyoming, Utah, and Colorado are some of the unconventional fossil fuels we have begun to exploit. Most of oil in oil sands and oil shale will not be easy to extract. The EROI for oil shale and oil sands are therefore very low. Oil shale's EROI is 1.1 to 1 to 4 to 1, and oil sands EROI is 3 to 1 to 5 to 1. Now let us consider each of the advanced methods for extracting fossil fuels, beginning with secondary extraction from existing wells. Part of the quest for more fuels has been to revisit old sites. When a site is first developed for fossil fuels, it is said to go through primary extraction, which is the initial drilling and pumping of available oil or gas. Primary extraction removes the fossil fuels that are easiest and therefore cheapest to harvest. Second, it goes through secondary extraction, which is when solvents, water, or steam is used to remove additional oil from a site that has already gone through primary extraction. With secondary extraction, materials are injected into the site to increase pressure and allow the remaining oil or gas to be extracted. While we do have technology to extract some oil with secondary extraction, we lack the technology to remove every bit of oil. Secondary extraction is expensive, and if the cost of oil and gas is too low, the cost of performing secondary extraction is not economical. For this reason, many U.S. deposits did not undergo secondary extraction. However, in the 1970s, the price of oil rose and companies started secondary extraction in the U.S. wells. This pattern has continued today. Another method for extracting hard-to-reach or previously unavailable fossil fuels is hydraulic fracturing, or fracking for short. This is a picture of a fracking operation. Fracking consists of breaking rock formations to release oil or gas trapped in impermeable shale. Hydraulic fracturing is used for secondary extraction and to tap new deposits. Fracking has allowed access to previously unusable deposits and has increased proven reserves and boosted U.S. natural gas production. However, people that live in areas where fracking is taking place have concerns. They often feel they must make a choice between financial gain and impacts to their health and drinking water. Some of the problems with fracking stem from the fact that this industry has been exempted from 7 major U.S. environmental laws. Specifically, fracking is not required to comply with the Clean Water Act and the Safe Drinking Water Act. These exemptions are due to what is commonly known as the Halliburton loophole, which is a policy pushed through Congress by former Vice President of the U.S., Dick Cheney, who also, interestingly enough, is the former CEO of Halliburton. The Halliburton loophole exempts corporations from revealing the suite of chemicals they use in their fracking injection solution. Fracking is also exempt from key provisions in the Resource Conservation and Recovery Act, the Comprehensive Environmental Response, Compensation, and Liability Act, the National Environmental Policy Act, Toxic Release Inventory under the Emergency Planning and Community Right to Know Act, and the Clean Air Act. Impacts of fracking are not yet understood, but some of the concerns are that Chemicals may leak out of drilling shafts and contaminate aquifers. Methane may travel through the fractures and contaminate drinking water. Methane and drilling chemicals escape into the air, causing unhealthy conditions. Immense amounts of wastewater are produced. Water may contain salts, radioactive compounds, and toxic substances. Wastewater from fracking facilities may be sent to sewage treatment plants that are not designed to treat these pollutants. Alternatively, wastewater from fracking operations may be injected into a disposal well underground. While the companies assure the public these disposal wells are not hydrologically connected to groundwater resources, this may not always be entirely accurate. Finally, fracking is suspected to be the cause of increased seismic activity, including tremors and earthquakes. One improvement that has been made in the last few years is that some facilities are now recycling their wastewater and reusing it in the fracking process. Today, we drill for oil and gas both on land and at sea. Offshore oil drilling platforms are massive structures that drill for oil or gas below the seafloor on continental shelves. These drilling platforms must withstand wind, waves, and currents. Offshore drilling produces 35% of the oil and 10% of the natural gas extracted in the United States. Shallow offshore drilling has been going on for decades. However, industry is moving into deeper and deeper waters, and this runs the risk of greater risks and danger. In 2008, Congress lifted a drilling moratorium along U.S. coasts. In 2010, President Obama said vast areas would be open for drilling. Then British Petroleum's offshore drilling platform Deepwater Horizon exploded. British Petroleum is most commonly known by the abbreviation of their name, BP. The Deepwater Horizon oil spill of 2010 killed 11 workers. This spill was the largest accidental oil spill in history. It took 86 days to plug. For 3 months, the Deepwater Horizon's explosion spilled 4.9 million of barrels of oil into the Gulf of Mexico. Researchers found that the rate the spill the Deepwater Horizon caused led to oil leaking uncontrollably from the well at a rate that reached 62,000 barrels of oil a day. The Gulf of Mexico suffered many impacts. Countless animals, birds, shrimp, fish, etc. died. Coastal marsh plants died, leading to erosion. Fisheries were devastated and fishermen lost jobs. For months, volunteers and workers paid by BP performed arduous physical labor to clean the beaches, and tourism on the coast of the Gulf states saw a dramatic decline. Public reaction to the Deepwater Horizon spill caused President Obama to backtrack. In 2011, he issued a 5-year plan that opened 75% of technically recoverable reserves to drilling. Discoveries of oil far offshore are encouraging more deepwater drilling regardless of our ability to deal with accidents there. For example, plans are underway for deepwater drilling in the Arctic. As the ice sheets melt in this area of the world, we can expect to see several countries, such as Russia and China, jockey for position to try to gain access to these waters for oil and gas drilling, despite the threat of frigid temperatures, ice flows, winds, waves, and storms. The proposed oil drilling in the Arctic could pose serious spill threats with difficult cleanup. Another environmental impact of fossil fuels is the devastation coal mining has on the land and water. As we discussed in a previous mini-lecture, 2 methods of harvesting coal are strip mining and mountaintop removal. Strip mining destroys large swaths of habitat and causes extensive erosion. Strip mining can also cause chemicals to run off into the natural waterways near a mine. This process is called acid drainage and occurs when newly exposed rock surfaces react with oxygen and rainwater to form sulfuric acid. As if sulfuric acid wasn't bad enough, the acid runs over rocks and causes heavy metals naturally contained within the rocks to leach out into the runoff leaving the mine. This runoff makes nearby waterways toxic. Acid drainage is a natural phenomenon, but like many other things, our actions have exacerbated the extent and damage of this process. U.S. regulations require companies to restore strip-mined land. However, the quality of the restoration effort can vary. Mountaintop removal removes tons of rock and soil, destroying immense amounts of habitat and creeks. Unfortunately, loosening of regulations in 2002 allowed companies to legally dump debris from mountaintop removal into valleys and rivers. Recall the oil sands of Canada I mentioned in a previous mini-lecture. Not surprisingly, oil sands development pollutes water. There are also concerns about pipeline leaks for the pipeline that carries oil from oil sands to Canada into the U.S. Consider the impact of what a spill might mean given the fact that the Keystone XL pipeline travels over the Ogallala Aquifer, which provides 2 million Americans with water. Pipeline leaks occur due in part to the fact that oil from oil sands is more corrosive than crude oil. Extraction of oil from oil sands uses immense amounts of water that becomes polluted and is held in massive reservoirs. Birds landing in the water of those reservoirs are killed by the pollutants. Also, strip mining for oil sands requires deforestation. Alberta's oil sands, mined 30 years ago, still have not recovered. Using alternative fossil fuels such as oil sands produces more CO2 than traditional fossil fuels. Specifically, oil sands produce 14 to 20% more CO2 than conventional oil. Shale oil is even more polluting. As you can see from this figure, our reliance on fossil fuels is caused by powerful extraction technologies, such as ones we have discussed previously in this video and government subsidies, both of which drive the cost of fossil fuels down. Our failure to develop alternative energy sources and our continual development of new applications of fossil fuels also perpetuate our dependence on these fuels. However, these fuels are being depleted because we 1. Have a growing population, 2. Are consuming more per capita, 3. Have limited non-renewable supplies, and 4. Poor fuel economy in automobiles. Both reliance on fossil fuels and depletion of fossil fuels drive climate change, cause severe health problems. For example, burning coal high in mercury releases the heavy metal into the environment. Mercury then bioaccumulates, poisoning animals and posing a threat to humans. Burning fossil fuels produces emissions that pollute the air and irritate the nose, throat, lungs, and can cause cancer. Burning oil and coal produces sulfur dioxide and nitrogen oxides, contribute to smog formation and acid deposition. Burning coal emits a variety of pollutants, such as sulfur, mercury, arsenic, and other trace metals. However, there are some things we are doing to reduce these detrimental impacts of using fossil fuels. To begin, we have developed clean coal technologies, which are technologies, equipment, and approaches to remove chemical contaminants while generating electricity from coal. For example, scrubbers can chemically convert or remove pollutants such as sulfur dioxide or nitrogen oxides from coal emissions. Another clean coal approach is to dry coal with a high water content so that the coal burns cleaner. Another approach is gasification, which is when coal is converted into cleaner synthesis gas, also known as syngas or synfuel, by reacting it with oxygen and steam at a high temperature. While clean coal technologies have reduced pollution, clean coal is still a dirty way to generate power. It is not surprising that oil and gas extraction modify the environment. More than drilling is involved in developing oil or gas. Roads, exploration, infrastructure, for example, housing, roads, pipes, and waste piles, are all required for drilling. Collection ponds are used to store toxic sludge. Drilling pollutes soil, air, and water and fragments habitat. However, there is one technology that has been developed to reduce the environmental impact of drilling. Directional drilling is when drillers bore down vertically into the ground, but then when they reach their preferred depth, they can change directions and drill horizontally. This allows them to drill for oil or gas without having a drilling pad directly above the oil or gas reserve. This technology reduces the number of drilling pads required for an area and therefore the surface footprint of the drilling area is smaller. That concludes this mini lecture on advanced techniques for extracting fossil fuels and their environmental impact and technologies used to minimize the environmental impact of harvesting and/or using fossil fuels. Please review the weekly outline and complete the activities for this week per the schedule set forth in the outline. Thanks and gig 'em!